So now that we have extracted and evaluated some data, we want to create a first chart, which will be a pie chart. For that, we want to look at the example file pie chart tutorial and open that. And the data that we want to deal with are the cases per country, the country names, the percentage of the population, so how large is the percentage of one country in Europe, and the percentage of cases per population. And then we want to sort these numbers to give them into the pie chart component in the right sorting. And the right sorting should be, in this example, the cases per country. So we have 30 values of cases per country, which we put into the key. And then we want to sort the country names, the percentage of population, and the percentage of cases per population accordingly. We will then have all of these numbers sorted by the cases per country. And then we can further process these into a pie chart component, which is actually not really a component, but a pie chart cluster. So the most important value for the pie chart shall be the share, which is in our example here sorted according to the case per country, and the share is the percentage of the population. This will be the angle of the pie chart. Then we have some more inputs for the pie chart component, which is the center point given here by 0, 0, 0, and the outside radius given by 20. We can also put in some inside radius, which will cut a hole in the middle of the pie. What we get out of this are the curved slices, so the pieces of the pie, and the midpoints of the arc. So let's look into that. When we open it, we see some yellow components, which are always of warnings, but that is not a bad sign, since this comes from the inside radius and we can just leave it out. So what we already see on the left here is our pie chart that shows us the percentage of the population of Europe per country. We do not yet know which country is which, and we also see that the smaller countries are kind of here, but the largest, which is this one, which will be Germany, that is the biggest country, is not at the end. And that is because we sorted the numbers not by the population, but by the percentage of the cases. So we see that Germany has the largest population number, but this country here has the most corona cases per capita. So what does now happen in the pie chart component? This year is a null replacer, and a lot of what is going on here is avoiding mistakes in computing for Grasshopper. So this just replaces broken items, and I will just leave out some of the explanation for why that is important, because it's already getting very long here. We have our share basically back then, and we want to give that share into another cluster inside the cluster, which is the radius domain. And the domain is the angle in radians that our pi piece was going to have. And there's basically only a lot of math in here. Some tree cleaning here and some trimming, and this is all to calculate the angle of a certain piece. So how large in radians is the angle of the pi, and then we want to create an increasing list of numbers, and that is for this procedure here, which you will often need. So we have this list of angles, and this tells us that the first number is this one, and the second is this one, and the third is this 0.007. But what we actually need is the difference always to 0. So it would be for the second number not 0.0050, but 0.005, and then add up the first number with the end 537 and add to it. And to make that for every number, we do that with a split and putting in this series of the length of the clean tree. So the series that we get out is one that is starting at 1, which is the expression that is in here, to get at least one item in the first list, and then have an upgoing number to 30 and split the list. And then what we get out of that is this list that is gradually taking more items off the list and then mass add these up. So we have always the distance to 0 from this number. This whole thing is basically made for when you have more than just one item fed into the component, which we will come later to. And it might appear then that you had to trim the tree because the tree has too many sub branches, and then you would check if the tree trimming is actually working. And here it is not, because we only have one path, a single path length of 1 to 30, and we want to filter that. So we look here, is the trimming here actually working, and check, does this actually create a number? And if it does not, just flatten this so we have the same structure as we gave it in. And then at the very end, we want to shift this list, because the first item that we get out is 2.0 times pi, which is not actually 0 degree, but it's 360 degree if we turn from radians to degree. So it would be the end of the circle, and we want to have the start of the circle. And that is basically because we shifted this whole list. And we do this whole thing because we really want to start at 0. And the easiest part of that is just shifting this list, replacing the first item with 0, and then we have this list of 0 to 5, and we also have this list of the first item to twice pi, so 360 degrees, and that is how we can create the domain. So we have this list, which starts at 0 and goes to the last value, and we have this list which starts at the first value and goes to 360, and then we can create a domain from that for the radian angle of the domain. And we also will give out what is actually the end of the domain in a second output. So the next thing that we would have to do is create arcs, and the arcs that we create are at first the outer ones and then the inner ones. And since we don't have any inner ones, this is 0 for now, but I can show you what it would look like if we gave input to the inside radius. It would create this hole, which are these arcs. If we preview this, it gets green. Great. And can turn it off again and delete the inside radius again. So what we want to have next is the lines connecting the inner and the outer circle. So since we don't have an inner circle, that will simply be the midpoint of that. And we want to create the lines that are connecting. And for that, we are looking at the endpoints, which are here, and draw these into line components. These line components are then the lines that are connecting. And since we want to have surfaces or areas in the end, we basically have to create the same lines but shifted by one again. So if we preview these two, they are actually the same lines but in a different structure. So what is happening down here again is a lot of testing. Oh, we can delete that. If there is this inside radius, and check if there is a null item and then filter numbers. And if there is not, we just take the center and repeat it by the length of the shares to have a list of center points, and then filter these lists with the filter component, which takes the index of the stream that you gave into it, and we test if there's something coming from the inside radius, and if not, it should just take the center points and then give it into the lines. What happens next is that we merge all of these points in the correct row, or order. So we merge the arcs first the outer arcs, and then the first line. Then we would take the inner arcs. If we don't have one, that will leave these out. That's not a problem. And then have the other line that is going back, and then have per pi piece we have 3 lines, and we want to join them together to have this closed polyline curve. We look if that has worked here, and we see closed planar curve. That is what we want to have. So sometimes that is not working, and we can simply check that if this join process is working, or if it has created only a whole circle, and it will show up as an invalid curve here. So we would transform this output from curved to text, and this gives us out the same if we look at it in the panel, but it is text now, and we can now check if this text actually contains an invalid curve as text, because that is the simplest way to check if a curve is invalid. And then we can call the index of invalid curves and have the simply only working planar curves, which are still 30 here, which is great. Now we are dealing with the, let's say, multiple input issue again. So if we have an input with more paths, then we would have to trim the tree like we did in the radius domain cluster and check if this is working, filter it again, and then we would have our curve slices, and we evaluate coming from way back here the arcs and evaluate it on the mids of 0.5 and have the arc midpoint and give that one out of the cluster. So we can close this now and the pie chart will disappear again, but we can look at how it looks. It still looks the same. And what we want to do now is, first of all, we want to not look at this. This comes later. We want to look at how we can now make this a beautiful pie chart. And for structural reasons, we will flatten and simplify this curve and grab this one for later purposes. But now we will get to a component which is creating hatches for you, which comes from the human plugin here in creation. It says create hatch, and we can preview that, and it will only show us that there are areas now which have some color. So first, let's look at what our actual colors shall be. And I've simply put up a gradient that is taken from the same list. So from the share of how large the population is, and sorted this up and taken the last item of the reversed this item list, which is to have the upper limit. And the upper limit shows me that the largest possible population percentage is 18%, which tells us, to get that straight, that Germany has 18% of the population of Europe. And now again, we can put all of these values into the gradient as a flattened list and get out the according gradient numbered, and can put that out into a custom preview, which is a component by blickfeld7.com. You can also just use the simple preview component and put in the geometry here. Now the basic material is white. Let's simplify this already because we know how it will work, and put in the color here. And now we see what the colors for our wheel would be. So I always use the custom preview, which is actually a cluster by Florian Frank and not really a component, which is why I cannot really tell you where I got that from, but you will probably find it on the internet. And I prefer to use that because it just shows the colors a little better and leaves out the lines of the edges. Okay, so now we have the pie chart, but we can do more. So what we are seeing is a pie chart. That is great, but we don't really learn from that, and that is because we don't know which of the pie pieces represents what. And we now want to just put the country tag towards the pie piece. And what we need for that is this this cluster that I made here from a few components, which I call 3D text. And what happens before is just some culling and aligning. So let's look into the 3D text component. It has a lot of input, and we already see how that is working then. What the basis of this is the justified text bake, which is also a definition by the human plugin. And then we have to do some math in here. As you didn't look, I tried to structure and clean it up a little bit. I want to go shortly through this. We have the text and the position, which is basically the most important of these, and the size of the text and the font. And these are pretty important for text. And next we have a justification, and I put this up to a list of 10 to control with one value the horizontal alignment and the vertical alignment. You don't have to worry about that too much. And then next we have the color, which goes in this create attributes component. And this is important to create the color for when it comes to baking. So the human components work the way that you can bake with a trigger, which is at the very bottom, and you can create attributes to be baked into these. And this is, for example, a color, which will be black by default, which is what this does. And then you can also put in a layer name to which these text shall be exported to or baked to. This layers is, of course, to a component of human. You put that into these attributes and put the attributes to the attributes input of the justified text bake. And then as we go out of that again, we see what we just have to put in there to get this working, which is possibly the more important part for you. We want to have the text. We take the text from the country and look just at whether the percentage has a larger number than 0.008, because here are very small percentages and the text will be quite unreadable there if we have too many texts. So we cull a few out and give these texts further, and have then a culled list which has a lot of zero values, which is important to keep the text according to their place on the geometry. And then we want to evaluate the position of the text, because we want to have our position not only as the point, but also aligned to a vector. And this vector shall be pointing from the center of the pie chart away. So we have it properly aligned. So we take the arc midpoint and the center point, evaluate the vector between these 2 points. Then we take the position, which are these points, and straighten their direction. So this is actually not a point, but a plane to give into this position parameter. So the position parameter always takes not only the point, but also the orientation of where this text should direct, and align this with the vector pointing away from the center and put that into the position input. As a font, we chose the IBM Plex Sans, which we just can put in via a panel. There's also some components, for example, the font list, which lists all of the fonts that are installed on your computer. The justification is 4, which is middle and left, and the according text will look like this. We have now all of the countries around here, and we see that Germany is here with the largest population, and France is at the very top of the cases with a slightly smaller population number. So now we know what this pie chart shows, but can we do more? Yes, we can, and that's why we look down here now. So we take this expansion factor, which is coming here in as a flat list, graphed and simplify it. We have this clear structure. We have to flatten it again to have the largest value of that, which is 0.14. And this shall be the domain for our colors. What we do now is, we also want to remap the numbers of the expansion factor because they're probably not matching the size of our graph. So we take a few guesses here and say, let's take the source of 0 to 0.1 at the source, and as a target domain we want to take 0 to 1 to have it basically each number 10 times bigger. We remap these numbers and put them into a scale component. So if we look at it again, we here have our pie parts, and the scaling point is of course the center point at 0, and we scale now these components. And what we see now is the scaled pie pieces, which represent the actual number of corona cases in these countries. Do now again the same thing as we did here for coloring. Let me unpreview this and preview this. As I said, this is the same as it was up here. We take the largest item, put it into here, and the values into here. Attributes, create hatch, and give the hatch geometry into the custom preview. We see now that bringing multiple dimensions to a circle graph is not always easy to read. And we here have now in this against the so counterclockwise, we have the number of cases lined up. So cases per country, France has in numbers the most cases of corona. We have in this dimension the population of the countries. We see Germany as the biggest country, France following up, then I guess it's Italy and Spain and Poland, and then all of these smaller countries. And then to really see which has the biggest percentage of corona cases per population, we have now scaled our pie pieces into a dimension of from the center away, which shows us that the Czech Republic has the largest percentage of corona cases. So much for the creation of one or more pie charts in one place. But how do I actually now place one or multiple on a chart? Let's find out how to make a coordinate system.